Say we're given the equation f of xy equals c. That's an equation of a level curve of f. C is a constant. So we get some level curve. Now, let's suppose we could parameterize that curve. So we could write it in terms of x of t, y of t, or just the position vector, r of t along the curve. Well, then we'd have a situation with the chain rule. So f depends on x and y, and x and y each depends on t. So I could take the derivative of both sides of our level curve with respect to t. And of course, the derivative of a constant with respect to time is 0. And this we use the chain rule. And now we recognize it as a dot product of the gradient vector with the vector dx dt, dy dt, which is just the derivative of the position vector. So reading from beginning to end, we have that 0 is equal to the gradient times r prime, gradient dotted with r prime. And that means that these two vectors are perpendicular. So we have that the gradient vector is perpendicular to the tangent vector along the curve, which is really the same thing as saying that the gradient is perpendicular to the level curve itself. In 3D, we'd have the same conclusion for the level surface. So what we can do is we can use the gradient to define a normal line. So if we have our level curve and some point, then the gradient tells us the normal direction, and we have the point in the normal direction so we can find the normal line. Or if we have a surface, some point on the surface, we have a gradient which tells us the direction of the normal line.